The universe is not silent. It is only playing hide and seek on a galactic scale, cosmic hide and seek. For countless millennia, humanity has stood beneath the night sky, staring at distant points of light and wondering whether someone out there is staring back. We have endured decades of silence, a cold stillness filled with mystery. But now, the golden eye of James Webb, JWST, is opening, carrying out a mission that seems impossible: to thread the needle through blinding light in search of the breath of distant worlds. Welcome to the journey toward the answer to the greatest question of all time. Are we truly alone? JWST is not merely a mechanical marvel. It is an entity sniffing the atmospheres of exoplanets. By analyzing stretched infrared wavelengths, redshift, it searches for the most fragile traces of life: water, carbon dioxide, or the provocative gas DMS. We are hunting for warm stones after sunset, rocky planets resting within the habitable zone, where liquid water could flow like the bloodstream of life. But the path to truth is always filled with illusions, from burning hopes of a second Earth to the harsh realities where data is nothing but lifeless noise. James Webb has taken us through the most violent emotional extremes. There are signals that have appeared once, then gone, defying every threshold of statistical significance. The title of today's episode: JWST and the Search for Life on Earth-like Worlds. Together, we will decode the newest mysteries as of February 2026, where the boundary between empirical science and hypotheses of life-bearing worlds has become thinner than ever before. Is this a new beginning, or only a solitary echo in eternity? Why, among billions of lifeless asteroids and deadly planets, does the name K2N-18b make the heartbeat of the scientific world accelerate so violently? The secret lies not in any glamorous appearance, but in a strange scent lingering within its thick hydrogen atmosphere. The NIRISS and NIRSPEC instruments of James Webb have performed a feat that feels almost mythical, threading the needle through blinding light from the host star to capture the faint photons that have slipped through the edge of the planet's atmosphere. This technique, called transmission spectroscopy, allows us to read the chemical profile of a world 124 light-years away. It is the moment when light becomes language, telling us what is unfolding beneath an eternal veil of clouds. And there, Webb saw what humanity has long yearned for through decades of silence: dimethyl sulfide, DMS. Pause for a moment to feel the weight of that name. On our own blue planet, DMS is not a product of barren rock or violent volcanoes. It is a pure biosignature, produced entirely by the tiniest forms of life in the oceans. If Earth is a living entity that breathes, then DMS is the breath of sea algae and phytoplankton. Detecting it at levels of 10-20 parts per million on a world resting within the habitable zone is not merely a chemical discovery. It is a dramatic signal, reaching 3 sigma confidence, where the probability of random coincidence is as thin as 0.3%. For the first time in history, we hold an empirical hint stronger than any previous claim of life beyond Earth. But K2O-18b is not a perfect Earth-sized twin in the way we often imagine. It is not a small warm stone after sunset like TRAPPIST-1e. It is a giant hybrid of ocean and hydrogen atmosphere, a Hycean world. With its low density and hydrogen-helium-rich structure, K2O-18b may possess a higher habitability potential than ordinary rocky planets. Imagine an immense liquid ocean covering its entire surface, where temperatures range from 0 to 40 degrees Celsius, kept warm by the greenhouse effect of a thick hydrogen envelope. This is a relic from cosmic dawn, inviting us to explore. The presence of DMS, even as a tiny ember in a roaring fire of infrared data, has opened a new era. We are no longer hunting for glorious civilizations or intelligent aliens from science fiction. We are tracing the first microbial pioneers, silent inhabitants living in the darkness of a distant star system. Webb's data suggests that the possibility of life-bearing worlds is no longer a far-off dream. Even if such signals can sometimes be tentative, appearing once, then gone in experimental measurements, K2O-18b represents our most authentic lead so far. It challenges every threshold of statistical significance and forces us to redefine our place in the universe. We are not seeking a second Earth to conquer. We are seeking confirmation that life is a universal melody, and K2O-18b may be the first note to echo across the vast emptiness after so many years of waiting. But, dreamers and travelers, pause for a heartbeat. In the cathedral of science, truth is not built on praise, but on the harshest trials of evidence. The signals of DMS, what we thought was the song of life, now stand under a suspended verdict. The universe, once again, reveals its infuriatingly elusive nature. We stood at the threshold of a great discovery, yet the door seems to close under the caution of human intellect. What we call a detection remains only tentative. In astrophysics, truth becomes law only beyond the 5 sigma threshold, the gold standard, where the chance of error falls to 1 in a million. But for now, K2O-18b remains trapped in the fog of imperfect numbers. By late 2025, as the first datasets were dissected by the coldest minds at NASA and Oxford, another reality began to emerge. The traces we believe to be biological may have been nothing more than an illusion woven from red noise. In that vast ocean of data, random instrumental fluctuations blended with starlight to create a false image. A chemical ghost that appeared once, then gone, defying our attempts to grasp it. Were we too hasty? Or did the hunger to escape decades of silence make us see a cold stone as a warm stone after sunset? A striking study in PNAS in 2025 dealt a heavy blow to optimism. James Webb, though the greatest marvel we have ever built, may still not be powerful enough to provide a definitive confirmation of life on distant planets. It is like trying to see through a blizzard with a telescope, where every snowflake is a systematic error capable of distorting the entire picture of a life-bearing world. Scientists began to fear. Perhaps we may never confirm any biosignature with JWST alone. The universe does not operate according to our wishes. Methane, CH4, and carbon dioxide, CO2, at K2O-18b are real. But they are not declarations of life. They could be products of strange abiotic processes, reactions between a rocky core and a hydrogen atmosphere unlike anything in our solar system. Life, if it exists there, may be only a tiny ember in a roaring fire of extreme chemistry, too fragile to distinguish from nature's chaos. The harsh truth is this: to thread the needle through blinding light once more and eliminate false positives, we need at least 1624 additional hours of focused observation. In modern astronomy, that is an enormous treasure. Every hour is a battle of funding and strategy for the right to stare into the dark. We may face the reality that James Webb will never give us a final yes or no. It only brings us to the cliff edge of understanding, forcing us to stare into the void and ask whether the shadow we see is life or merely the reflection of our own longing. In Eastern philosophy, this is the state of non-being, present yet absent, absent yet present. K2O-18b remains there, orbiting its star with challenging orbital eccentricity, guarding its secret like an artifact from cosmic dawn. It reminds us that we cannot demand the universe to speak. The universe is not silent because it has nothing to say. It is silent because we are not yet quiet enough to listen. The disappointment surrounding K2O-18b in early 2026 is not an end. It is the purification of reason, stripping away fantasies to prepare for a more rigorous search. We have not found them yet. That does not mean they do not exist. It only means that truth is still playing hide and seek somewhere deeper, where even James Webb has only touched the outer shell. The breath of life remains infuriatingly elusive. Yet that difficulty is precisely what gives the journey its value. If life is a tiny flame, then we are the fire seekers, willing to be burned by reality in exchange for the light of truth. Even if the doors of K2O-18b seem to close within uncertainty, we are not standing at the finish line. In the eternal flow of knowledge, every failure is purification. Every illusion dispelled is a step closer to truth. James Webb may not have brought us a definitive confirmation, but it has achieved something greater. It has proven that humanity is capable of reaching for the breadth of distant worlds. We have shown that we can thread the needle through blinding light to analyze relics from cosmic dawn. The decades of silence have officially been broken. We are no longer observers from afar. We have become decipherers of life's code across space. The search for life beyond Earth is burning hotter than ever, like an ember in a roaring fire. In January 2026, the Pandora mission was officially launched, carrying hope of resolving what Webb left uncertain. Pandora will help remove stellar noise, allowing us to peer through the fog of uncertainty and determine whether worlds like K2O-18b truly nurture living oceans. If K2O-18b harbors life, it may not be a radiant civilization, but the silent existence of microbes in a deep ocean. Life does not need sunlight, nor our recognition it exists as a primordial instinct of the universe. This clears the path for future giants such as the Roman Space Telescope or the Habitable Worlds Observatory, eyes focused entirely on Earth-sized planets, searching for true warm stones after sunset within the Milky Way. The universe is still playing hide and seek. Signals may appear once, then gone, but human longing is infinite. Perhaps we will never know for certain with James Webb alone, bound by harsh limits of technology and nature's noise. Yet it is precisely this infuriating elusiveness that keeps the flame of curiosity alive. We stand at a pivotal moment in history. Every molecule found, every orbital eccentricity measured, is a fragment of the grand puzzle of life-bearing worlds. We are not alone, because we have each other, and because we have the courage to stare into the darkness without fear. The universe may not have been designed for us, but it allows us to witness its beauty, however long this journey takes. Whether James Webb is the final answer or not, the fact that we dare to ask is already a victory. Keep hoping, because in a universe where anything can happen, life may not be an exception, but a promise still waiting to be fulfilled. The universe always knows how to mock the ambitious. In early 2025, a wave of excitement swept the scientific community when a Cambridge team announced the presence of DMS and DMDS on K2O-18b. At 3 sigma confidence, humanity felt it had touched evidence of a liquid ocean stirred by microbial activity. It was the moment we believed we had threaded the needle through blinding light to find the sigh of life. But in science, dawn is sometimes only an optical reflection. By late 2025 and early 2026, independent analyses poured cold water on that burning hope. Reports in astronomy and astrophysics and R-EXIV preprints performed a full dissection of data from Webb's 3 sharpest instruments, NIRIS, NISPEC, and MIRI. The result was harsh. The evidence for DMS fell below 3 sigma. What we believed were biosignatures were instead identified as instrumental noise or artifacts of incomplete atmospheric models. Once again, life became infuriatingly elusive. The signal appeared once, then gone, leaving us surrounded by doubt. Still, do not let disappointment eclipse what Webb truly achieved. James Webb has definitively confirmed methane, CH4, and carbon dioxide, CO2, undeniable notes in K2O-18b's atmospheric symphony. It confirms this is a true Hycean world, a liquid ocean hidden beneath a vast hydrogen shell, where low ammonia suggests the presence of water. We simply have not yet found the signature of whatever might live within that ocean. Looking to neighbors like the TRAPPIST-1 system, the reality is even harsher. Though Earth-sized, planets like DIRD and A have been stripped of illusion, programs like DREAMS confirm they lack thick Earth-like atmospheres or are bare rocks under the lash of red dwarf radiation. No warm stone after sunset was found there. We are at a dramatic crossroads. Only 1 to 3 more transits with MIRI 8 to 24 precious hours could push confidence to 4-5 sigma, enough to turn hypothesis into truth. Yet as of February 2026, the universe still holds its final cards. No new data has been released to quench humanity's thirst. This game is a tiny ember in a roaring fire of unanswered cosmic questions. Webb may not yet have found a clear biosignature on an Earth-sized planet, but it has shattered decades of silence. We may not have found life, but we have found how to search for it. K20-18b and James Webb have taught us patience. Life may be hiding in the cracks of data, waiting for a moment quiet enough to be recognized. Until then, we will keep looking up, piecing together fragments of life-bearing worlds, because truth belongs only to those who never surrender to the silence of the stars. In the search for warm stones after sunset, a warm stone after sunset, James Webb has led us through the strangest corners of the Milky Way. But reality is rarely as sweet as poetry. By the early days of 2026, we still have not found a single biosignature on planets that are truly Earth-sized. The legendary TRAPPIST-1 system, once hoped to be a paradise garden of rocky worlds, has delivered somber notes for reflection. Observations in 2025 of TRAPPIST-1e suggest it lacks a thick, Earth-like CO2 atmosphere. The brutal radiation from its red dwarf host star seems to have stripped away every chance for complex life to take root, leaving behind planets as barren as relics from cosmic dawn. The universe not only plays cosmic hide-and-seek, it also displays extreme creations. We have seen Alpha Centauri AB, a giant gas world orbiting the star closest to us, yet far too large to host life as we know it. We have seen PSR J 2000, 322, 2650b, a bizarre planet coated in carbon, soot and diamonds, circling a dying neutron star, a place where life is unthinkable, or the latest candidate from Kepler data, HD 137010b, a truly Earth-sized planet, yet trapped in the cold of -70 degrees Celsius. All of these were signals that appeared once, then gone, appeared once, then gone, from the list of potentially habitable worlds, before Webb could provide atmospheric data to confirm anything. But hope, like a small ember in a roaring fire, is being rekindled by a new ally. In January 2026, the Pandora telescope officially reached space. Its mission is profound: to monitor the fury of host stars so that Webb can subtract the noise, allowing us to thread the needle through blinding light, with greater precision than ever before. Pandora is the key to confirming whether Hycean worlds like K20-18b truly carry signs of life, or whether they are only chemical mirages. We are standing at the edge of a great turning point. With Pandora's support, and soon the Nancy Grace Roman Space Telescope, 2027, we will hunt for thousands more Earth-sized worlds. If K20-18b is confirmed to truly contain DMS, it will be a thunderbolt that shatters decades of silence. It would prove that James Webb is not only photographing the universe, but also capable of recognizing the breath of distant microbes, opening the possibility of life-bearing worlds, existing everywhere across the cosmos. The truth is still flickering in and out of view, infuriatingly elusive. But it is precisely that uncertainty that binds us together, driving us to keep staring into the darkness to search for ourselves.